Welcome to my SimpleDungeons tutorial and add-on. This is a tutorial and an overview of the add-on I created for Godot called SimpleDungeons. It allows you to easily create these procedurally generated 3D dungeons based on prefab rooms. I'm going to leave a link in the description to the GitHub repository for this add-on, and I'm going to be using the sample project included in that repo. So the repo itself is a Godot project. If you want to use the add-on as standalone, you just copy the SimpleDungeons folder from the add-ons folder of the project to your project's add-on folder. Or if you want to test it out and open up the sample project, you can just download it from GitHub and open up the resulting folder in Godot. If you're not going to use the sample project to follow this tutorial, make sure you go into project settings and then enable the add-on under the plugins tab. Make sure that's enabled. I got a lot of good feedback when I first released the first version of this add-on, so I actually just recently went back and added a bunch of features that people had asked for and just improved it, fixed bugs and stuff. So hopefully it's in a pretty good state for people to use, and I hope that this tutorial will also be useful in because it didn't have a lot of documentation before, so I want to go over just how to use it, the basics, and also go over some of the code at the end and just help people understand it a bit better. So yeah, the first thing I want to go over here is everything is based on this voxel grid, kind of like because everyone's played Minecraft probably. You just have these voxel blocks, and the rooms are defined in voxel dimensions. So everything that you just saw in that demo here that I just showed you initially, it has these prefab rooms that I've defined, and I have a whole list of them. So like every time you create a new dungeon, you'll have a set of rooms, and you will configure a few things like the corridor here, which every dungeon needs, which is what is used to connect all of the bigger rooms together. This becomes the hallways, the connecting pieces. And you define the size in voxels. So corridors have to be 1 by 1 by 1. And this will be like 1 voxel brick on this grid. And all the doors fit into here. And basically it just runs this algorithm to connect the rooms together. Like everything is done, like whatever room you create. The only thing the algorithm really cares about is the voxel shape you defined these rooms in. Like it doesn't care about the models or anything. You just define whatever dimensions that you want your room to be in these voxels. So here's another one of the rooms I used in the demo there. It is 3 by 2. And then I define the doors. And doors, a door isn't, it can be, but it doesn't necessarily have to be like a door model like this. But all a door means is that you can have an optional door or a required door. And if it does have a door, that means you're going to need to have a connecting piece, or the algorithm will create a connecting piece when it sets up all of the rooms. So if I go and visualize the generation here, what you'll see is it's placing all of the normal rooms, and then it starts placing the room connections after that. And all these little room connections here are the corridor pieces, if I can select these. Yeah, so like each of the rooms that generated here is 1 corridor piece. And it's generating corridors to connect the other rooms together that you set, and placing the corridors like in a pathfinding algorithm to connect whichever sides you set the doors to be on. You can have optional doors, like on the corridor, all the doors should be optional, which means the algorithm doesn't necessarily have to connect them. Or you can have required doors. So like this is my entrance room where maybe the player spawns in here. And in this case, like I would definitely want all the doors to be connected, because that means like there should be a path leading out to the rest of the dungeon. If it was an optional door, the algorithm may or may not connect it, but it's not required to connect the door to the rest of the dungeon. You can also have multi-level rooms, like so they can be greater than 1 height, greater than 1 in the Y size in voxels. And this will be required, like for stair rooms, you need a stair to connect, like in this generation here, it's a multi-level dungeon. So in that case, you need some way to be able to connect the various floors, and you do that using stair rooms. So to create a stair room, you make a room that's greater than 2 in height, and then you mark it as a stair room to be used in the stair connection phase where it connects floors. And then it needs to have doors, obviously, that are able to be connected out to the multiple floors. So it has to be able to bridge two separate floors together by having doors on separate Y positions for one room. You can also pre-place rooms by adding any Dungeon Room 3D as a direct child of a Dungeon Generator 3D, and then you're going to want to force align it with the grid using this button here in Editor. And this will basically allow you to put like a pre-placed room that's going to stick in whatever position you place it at, and basically the dungeon will generate around it and make it interconnected into the dungeon, but you'll be able to like choose exactly where it spawns in, and it will stay there and kind of connect in. So maybe like you could use that for like an entrance room. Like if you have a mansion, you could pre-place a room like right at like the front door essentially, and then it would essentially, why isn't that working? Oh, because I have it marked as a stair room. Yeah, you could place it at the front like this, and then it would like generate around the rest of the dungeon, and then you would have this door essentially going out that you could connect like with your environment, like if you had terrain or something. And yeah, so the pre-placed room should be pretty useful. That was a new thing I added. You can also do stuff like this, where here I like predefined the room placement phase, or I like supplied all the rooms in manually, and then I was able to set the exact positions and what exact rooms I wanted. So you don't necessarily have to rely on randomness. If you want like a really particular setup for your dungeon, you could hook into the custom get rooms function, and which I'll go over that later. I actually forget exactly what it's called, but I just changed the name a couple times. But yeah, essentially there's a function you can hook into. I'll go over this a little bit later, more complicated, but you can define all the rooms that you want. So here I have red and blue rooms, and I made it so the red rooms spawn randomly on the left side and the blue rooms on the right side. So this was another feature people requested where you can have more fine-grained control over how the dungeon spawns in and like what rooms spawn where. So yeah, that's actually called the custom get rooms function. So here I'm using it to spawn in these blue and red rooms in set positions and have them randomly placed, but within my control. So the red rooms are on the left side and the blue rooms are on the right side. So I'll go over this a little bit more later, but yeah, that's how you do that. That was another feature people wanted. So yeah, hopefully that gives you a good overview, and now I will start on the tutorial portion of this and we'll learn more about how to use this add-on. So what you're going to want to do to use it is search for Dungeon Generator 3D and your Add Node menu, and that should show up as long as you have the plugin enabled in project settings. So if you have a Dungeon Generator 3D, you'll first see an error that it's going to complain there's no room scene set. We'll do that in a second here, but it has all these default settings here: corridor room, room scenes, and you set it in the Dungeon Generator 3D properties. And so you're going to define all the rooms that the dungeon is going to use for generation as separate scenes in your project. So I'm just going to make a folder here called example rooms to house all the rooms we'll create together in this tutorial. And I'm going to add a scene, and you should have it always inherit from the Dungeon Room 3D type, which should also be in your nodes menu. So whenever you're creating a room that's going to appear in the dungeon, it should inherit from the Dungeon Room 3D, which just extends node and just provides you this empty scene, which can interface with the dungeon generator. So yeah, first thing we'll do here, I'm going to add a CSG box 3D to our scene, and I'm going to use the CSG feature in Godot, which stands for something, shape something, generation something. I forget what it stands for, but we're going to use that feature. It lets us make these boxes, and essentially do like a basic version of 3D modeling within Godot. So for the corridor, I just made my box 10 by 10 by 10, which is the same as the voxel scale for the room here. And then I'm setting the a smaller box inside of it and setting it to subtraction. And then I'll also make another subtraction box, which makes these cuts for the interior and for the doors. And and so it's going to be a corridor, so it needs 4 doors on it, 1 on each side. This is what's going to be used to connect all the rooms together and make hallways between them. So there's going to be 4 cuts, 1 on each side for the doorways, so the player can travel through the hallways. And I'm making 2 cuts with CSG Box 3Ds right now, but I'm actually going to turn that into 4 in a second here. You'll see at the top it says to add doors, you use nodes prefix with the names door or door question mark, all capitals. And so you'll see what I'm going to do here. I'm going to duplicate and just change the shape of these CSG subtractions, which are cutting out the interior of the box. And I'm going to make sure there's 1 for each side of the box. And then, I'm going to rename this the room cut separately just so I can differentiate them here. And I'm going to do the same for all 4 sides. And I'm making sure there's 1 cut and it's positioned aligned with the wall. Because you'll see here in a second, when we rename them with door as the prefix, so door or question mark door or door question mark, then a little door marker will appear. And basically how it works is it will detect which side of the voxels or which like face of the sides of the room, which like voxel face it's on, based on the node's position or based on like the origin position of that node. And in that way, the doors will be detected and we'll know which sides to connect the room on. You can use any type of node 3D to do this. This includes CSG Box 3D. So I'm just like including the door marker coupled with the subtraction node. And also, if it doesn't have a question mark after the door, it has to be all capitals, and question mark for optional or non-question mark for required. Required doors will turn green, and those are the ones which the algorithm will always connect every time. Optional, it may or may not. Corridors have to have all optional. And yeah, like I said, you need to have it like position, like the way it detects where the door, which direction it's facing. And if there is multiple, like if it's more than 1 by 1 by 1, you could also have it on like any voxel. The way it detects is it like whichever face it's closest to, it will make the door on that side. So like if, like the 2 CSG box cuts were overlapping over here, it's going to detect 2 doors just facing this way. So it'll say the corridor has overlapping doors. And it should give you some good errors and warnings. I try to put as many like errors and warnings as possible to make it easier to use and make sure if it gives you any problems, you can see exactly what went wrong and where it went wrong. And yeah, you could use like any type of node for this. I'm using CSG Box 3D just for this tutorial. Like if you had 3D models for your dungeon rooms, you might like set it up totally differently and not use CSGs at all. And the node for doors, it could be any type of node. So I just changed the type here to a regular node 3D. And you'll see it's just detecting where the door is based on the position of the node 3D and which side it's closest to. So you're just marking like, it's called a door, but really it's just a connection point for the algorithm, either a required or optional connection point. Hopefully that makes sense. So yeah, these corridors will be used in the pathfinding part of the algorithm when it pathfinds a way to connect all of the normal rooms together with these corridor rooms. So we'll start on the rest of the rooms now. So yeah, I'm going to do next a stair room in a very similar fashion here. I'm just going to call it stair and have it also inherit from the dungeon room 3D. And a very similar setup here. I'm actually going to copy over the room here. Or actually, instead, I'm going to set the voxels first. So you'll see here, so it's a 2 by 2 by 1 in size. And then yeah, I'm just going to do very much the same thing with setting the room shape with the CSG box 3D, and I'm just having it match the voxels exactly, because like that's like the boundaries of where it's going to generate, so you want that to match up to the size of the room usually. So yeah, you'll see here with the doors, same concept, like just whichever side of the voxel faces it's closest to, that's going to detect where the door or the connection point is going to be leading to, and it'll give you that arrow as the notifier. And just making a cut for the interior of the room just like before. Because it's a stair room, I'm going to change the colors to make it a little bit easier to see against the corridors, and I'm also going to add a ramp inside to allow the player to walk up and down and get to the different floors based on that. So yeah, for the ramp, I'm just going to use a CSG Polygon 3D, delete one of the default polygon points, and then just move it into place for a ramp between the levels connecting like the 2 floors that the room spans. So we have this 2-floor room, and then we have these doors leading to both of the floors. Stair room could be any number of floors, but probably for the simple case, you just want 2. And then you mark it as is stair room with that option on the right. And that'll tell the algorithm to use it in the stair phase. So after placing the normal rooms, you might also have to increase the maximum count to ensure that there's enough to place for all the different floor connections, connecting all the floors of the dungeon. And then, yeah, pretty much the exact same thing here. I'm going to create one last room here for the demo. I'm just going to call it living room 2 by 1 by 2. Same deal, CSG box 3D. Make it to the shape of the voxels. And then I'm going to cut out the interior of the CSG box 3D. And then I'm just going to set the doors up so they are aligned with the different sides. And then one thing to note here, I'm being kind of sloppy with some of the door positions here. It might be, I'm watching this back, I just recorded this. They might be perfectly aligned, but like one thing to note is you're probably going to want to spend some time making sure like all your doorways are aligned with each other. So like you're going to want to have them at the same size and offsets of your voxels, because like when different room types are connecting, you're going to want their doorways to like match up perfectly as well. And to do that, you just have to like measure your door position relative to each voxel. You might have to like count the size in voxels that you set on the room in the dungeon, which by the way should be the same, and just like do some math to, you know, make sure it's like perfectly halfway in between the voxel size, whatever you place it at. One thing you have to make sure of is you have to make sure the voxel scale is the same on your room. So I went with the standardized size of each of my voxels being 10 by 10 by 10 units. And if they're not scaled the same, it'll warn you and it'll scale the rooms. So once you have the room scenes, you can just select multiple of them and drag them into the room scenes array on the Dungeon Generator 3D. And then same thing for the corridor. You can just place that in your corridor room scene property on the Dungeon Generator 3D. And then yeah, just with that, you should be able to run it and you'll get this randomized generated dungeon. And you'll see all the rooms we designed are here. And I actually didn't remember to enable collision on the CSG box 3Ds, but that's okay. You can see it generated all our rooms randomized here, and it will generate them based on whatever seed it uses every time. And so like if you use the same seed, it will generate the same configuration of rooms. And yeah, now I'll just go in and enable use collision on all my CSG box 3Ds. And then you'll see if I rerun it after enabling collision on all of them, now that we'll have properly colliding rooms here that we can walk into. I'll fly into them, and you can see we can walk through this randomly generated dungeon different each time, unless you specifically set the seed you wanted to use. And yeah, I was a little bit sloppy on my CSG box cuts here. It looks like I made some on the floors by accident, but yeah, if you were making your own dungeon, you'd probably spend more time just doing a quick rough thing to illustrate the usage of this add-on here. So yeah, I'll talk a little bit about the options on the Dungeon Generator 3D. So first thing is whenever it generates, it'll have a seed that it used. So this was the dungeon that I just showed, 14706 something something something. If you paste any seed into the generate seed property, you can regenerate the exact same dungeon and know for sure like how it's going to generate every time. This is also what would allow for, like, if you had this in a multiplayer game, you could just make sure each player got the same seed on generate, and then generate on ready, also relevant if you're using this for multiplayer. You might not want to generate it on ready. You might want to set the seed first, and then you can call the .generate method yourself with the seed as an argument, or just leave it or set it on the generate seed property. Either works. Yeah, so generate on ready, that means like when the scene starts, it'll automatically just fire off the generation. Retries, so like, for example, in the room separation phase so you place all the rooms and then it's going to try to see if there's any overlapping rooms, because a lot of times they're just randomly placed. Some of the rooms might be overlapping with each other at that point. So to get like, make sure they're separated and to also help with randomness a bit, we will just separate the rooms, and then, yeah, if it doesn't correctly generate, either the separation phase or maybe some other edge case where it couldn't perfectly pathfind through all the rooms, then it can restart the algorithm as many times as you put here. So maybe in a real game, you would put like 2 or 3. Anything beyond that, you should probably not have it failing beyond that, as long as your dungeon is set up correctly. But maybe just have it like as 1 in testing, and then as long as it never fails, maybe have it like 1 or 2 above that, and it should never fail. I think the only places where it would fail is, in the separation phase, or like really weird edge cases where the door pathfinding wouldn't work correctly. Like one situation I could think of would be like if somehow it randomly generated 2 rooms with only 1 door and they were like both blocked into a corner, like pathfinding could potentially fail there. So this isn't like a foolproof, like there's no way to know perfectly if a dungeon is going to 100% sure connect like before generating it. So that's why we have these this retry option. And then iterations, if you highlight any of these properties, I put as much documentation as I could on. It has place room stage, place stair stage, separate room stage, and connect room stage. Each of these stages, it'll go through and iterate through 1 step on each of the functions for each of those stages. So like place rooms, 1 room placed, that's 1 iteration. 1 stairs placed, that's 1 iteration. 1 attempt to push all the rooms apart, that's 1 iteration. So 250, I mean, if you shouldn't probably need to go too high as long as your dungeon is not like massive, but you might need to adjust this, probably, hopefully not. Yeah, like it's also possible it could get stuck in some cases separating and like never separate, so that's why we don't just let it go infinitely. In that case, it would be a fail and it would retry. Generate threaded. This could be useful. You can do part of the dungeon generation in the background. So like it doesn't actually spawn in the rooms till the very end. And you can do that all in another thread to speed up the generation time, and it'll still like probably lag for a second when all the rooms spawn in, but as far as I know right now, that's kind of unavoidable in Godot. That's just a product of spawning the scenes in, and yeah, like even because the scenes are like preloaded because you have them set as a packed scene here, it's still gonna have some amount of lag, I guess, like loading in like shaders and other small things, but nonetheless, generated threaded will speed it up quite a bit. This editor button to generate dungeon, I showed this before, but this lets you generate in editor if you click this. And yeah, it's going to let you generate the dungeon in editor. And remember, this is the same seed as we used here. It prints out the seed every time it generates. This was the one we just walked through in the example there. and generated with the same seed to replicate the exact configuration of the dungeon there. So there is that. And then A star options. So I try to put a couple options here to work with A star. If you don't know what this is, probably just leave it on Euclidean. Euclidean point of that is to encourage it to have straight hallways rather than like zigzagging weird ones, which can happen with Dijkstra's and Manhattan heuristics. Euclidean heuristic, and then corridor cost 0.25. Encourage it to join together existing corridors. If that was just one, that means the algorithm doesn't have an easier time. Don't encourage the algorithm to connect corridors. Same with rooms. So that would result in like more corridors and potentially more like messy and excess corridors connecting the rooms together. So having the corridor cost and the room cost set lower means it's going to encourage the algorithm to compress and connect corridors into a more efficient space so they're not all over the place. And at the end here, there's a stage where I am making sure so it pathfinds through the room, but that might not connect all the required doors. So at the end, I just have a stage where I pathfind to the from the rest of the required doors that aren't yet connected to the closest rooms. And so I just set the cost for running through rooms at that point to 2 to just encourage it to have some more interesting corridor paths at the end. So I tried to make some options you could play with there to maybe see if it makes any difference for your dungeon. If you have any suggestions for options, I mean, I guess leave them down below. I tried to keep this simple while also giving people a few options to choose from here. And in terms of the debug options here, this is mostly like for the debug grid. You can also show that in game if you want. And do you want to place the dungeon? Even if it failed, maybe that's useful for debug, but you can also just click visualize generation, select the wait time between iterations, and it will like wait 100 milliseconds between each phase of the dungeon generation or each step, allowing you to kind of visualize and see what's happening. Like if it's failing to generate, you'll be able to see where. And yeah, this was just a debug thing I put in for being able to like see through a bunch of dungeons. So whenever you press N, if you have this selected, it will cycle through debug drills. In terms of the pre-placed rooms, I'll illustrate that here. So you could just add a room as a direct child of a dungeon generator 3D to pre-place it, and you'll see like when it generates, it has this room container, and pre-placed rooms are just direct children of the dungeon generator 3D, and they're not in the rooms container. So here, maybe I just want this room to always spawn in the top left corner there. Just pre-place it there. Another potential use, maybe I want like an entrance to this dungeon to be able to like connect to the outside of my level, whatever that is. So like here, I'm placing this one by one voxel room here on this side of the dungeon facing the player's spawn point. And then I'll just add a door to the back face of it facing into the dungeon. And then I'm just going to make a path back to the player's spawn. And remember, like the dungeon doesn't care about like the models or anything related to it. All it sees, it doesn't see the collision or anything. All it sees is the like voxel shapes that you define, as well as the doors you define. And that just defines where it's going to spawn the corridors that you set, where it will spawn those in. So I'm basically just reserving this space to be empty, essentially, by marking it as a pre-placed room, and then requiring like one of the interior parts of the dungeon to connect there. So we have this walkway into the dungeon that's basically going to be connected into the rest of the dungeon by corridors. So when I generate it, you'll see it connects in to that walkway, the pre-placed rooms up there, and then also our entrance kind of room here with the walkway connects in via corridors as well. And now if I run it, you'll see, of course, it's the same result. Like it just always reserves any pre-placed rooms that you put there. It just reserves their place, and it's going to snap them to the grid if you don't press that force snap to grid button that I showed earlier. Yeah, it's just going to leave them or whatever they are aligned in the grid, and then like connect them, make sure that they're connected just as it would any other regular room within the dungeon. And yeah, actually this is the same seed that we used before, so it's placing the rooms in the same spot. It has the first room in the same like corner piece here. And yeah, it's just like connecting it in with the pre-placed room and the entrance room thing. And yeah, whenever you pre-place rooms, make sure to pay attention to this force align with grid button under the pre-placed room options. If you don't press that, it'll do it for you. Just make sure like because all the voxels need to be aligned with the dungeon grid. And yeah, so one thing I am going to do next here is clean up these room scenes. So first, the corridor scene here. One thing you're probably going to want to do, I'm going to fix this, these like cuts going to the floor here first, but one thing you're probably going to want to do is like adjust the appearance of the room based on the rooms around it. So like one common thing you're going to do is remove the unused doors. So for that, I'm going to add a node with a built-in script here on it, and I'm just going to call it removed unused doors. And I'm going to add a function in it that I can call to remove the unused doors on the corridor room above. And every dungeon room has a dungeon done generating signal on it, which is called after the dungeon generator 3D finishes generating. It's going to call on all the rooms and make them emit that signal. So I'm going to connect that signal to the remove unused doors signal on this little component node I put in here to house this script. And I just connected the Dungeon Room 3D's signal to the remove unused doors method here. And so this will be called whenever the dungeon is finished generating for any extra stuff we want to do to the doors. And for this, we're going to use this get doors method on Dungeon Room 3Ds. I got to write some documentation for this. Hopefully by the time you see this video, I will have written some, maybe not if you're a really early watcher. I'm going to try to get done, but this tutorial is the docs for now. You can ask in the comments if you have any questions. But we're using this get doors function from the Dungeon Room 3D class, and we're going to call on the corridor object here, we're going to call the get doors, loop through them, and then we'll use this method on the door object, get room leads to, which returns either null if there's no room that door is leading to, or it would, if there is a room, it would return the room. And then so if the room leading to is null, we're going to get this door node variable for the door, which will just be like whichever node 3D, and free it if the room is leading to nothing. And actually, to make this a little bit more modular here, I'm actually going to remove this signal here. I'm going to connect it in underscore ready manually, so I can just drop this node into all my scenes. If you're using like models rather than just CSGs, the process of this might be a little bit different, but it's the basic concept of you can check each door, and if the door is leading to something, then you want to leave the door there. But if it's not leading to something, it will free the door like this, and then kind of makes more sense to have a closed dungeon, not just have doors leading into an abyss of nothingness, because they're like hallways. Yeah, so it's not like Swiss cheese. And yeah, to go over this some more, definitely check the GitHub. Hopefully we'll have a wiki up pretty soon. I got to get on that to just explain more in depth the usage of this and some of the structure, and I'll probably go over the source code a little bit more in depth at the end of this video. I have a couple more things I want to show. But yeah, the basic concept here is the functions of interest here that you would use. And you can also look at in the Simple Dungeons, we have some sample dungeons here. You can look at like in the kit at the beginning I showed, the dungeon at the beginning I showed, we have, let's see, like the living room here. I'm doing that here. Like you'll notice that the dungeon was completely closed off. So when these doors aren't used, I swap out the models for a different set of them. So in this case, you can have like that pattern where it's like a node component. You connect the signal, or what I did here was I I inherited Dungeon Room 3D. Either one works, really doesn't make a difference. I put in both actually just to show there's two ways of doing it. And yeah, in this case, this other function of interest on Dungeon Room 3D, there's get door by node, and then you can pass in the door node, which would be like the node 3D, which is used for detecting the door position. Not that one. Detecting the door position like this. And then, for instance, so yeah, you can't just remove the CSG cuts on this because there's models. You would have to, I'm using the CSGs for collision here, and then I'm also using models. So what I do in this one, I get the door by the node, and then I'm just removing the specific model in the same way, or setting a wall model to visible if that's appropriate as well. So basically I'm just swapping the visibility of my models depending on how the dungeon ended up connecting, and I'm just querying the Dungeon Room 3D's doors, seeing if they lead to anything. If they don't lead to anything, then I want a wall. Where's the wall? I want a wall to be shown like that. And if there is a door, like I want like a door. So basic premise there, the two functions of interest are get door by node, lets you get the door object, or get room leads to. Or if you're doing the CSGs like this, there's also the get doors function, which is on the Dungeon Room 3D object. So get doors, get room leads to, and then there's also the get door by node function. And you can refer to the example scenes in the Simple Dungeons GitHub repository. It'll be in the Sample Dungeons folder. Some of them are attached as built-in scripts, and then I think I also have some of them as built-in or like component nodes, like we set up here. I think the dev textures, some of them, hopefully, yeah, some of them use component nodes. Maybe I should have had it as the same thing. Maybe it's a little bit confusing, but try to show like there's a couple different options of doing this, and yeah, that's the basic concept. So looping through the doors, if the door doesn't lead to anything, then we free the door node, which in this case, the door object's door node property, that would just lead back to the door cut, because this is what we're using as the where are we? Getting lost here in my project folders. Yeah, like we used the CSG cut as the door node, and the script will go ahead and save that in the door, and then you can access that with the door underscore node variable on any door. And so I'm freeing the CSG cut into the door properties. And yeah, get doors, it doesn't return like the CSGs. It's actually a door type. Dungeon Room 3D's door type, specifically a class made for encapsulating some logic for doors on the Dungeon Room 3Ds. So yeah, hopefully that explains it. Refer to the example dungeons in the GitHub repo. If you have any questions, you can leave them down below, and also make sure to check in the GitHub repo. I'm going to try to get that wiki up soon to have a lot more documentation of this. So yeah, hopefully that helps. So yeah, you can get pretty fancy if you wanted to modifying the dungeon rooms in post, but for this I have this simple component node I made. I'm just going to place it on all the rooms since they're all just doors made with CSG cuts, using that same idea of just freeing them and getting all the door nodes on the parent. I can just plop this script into all my dungeon rooms, and then pretty cool. We have this, that door is technically connected to that invisible room, so that one's not getting removed, but all the rest are removed in this kind of enclosed dungeon that we can now walk through, enter from outside. Pretty cool. So yeah, you get pretty fancy. I think there's a bunch of options. You could probably find other stuff you want to do, like if you just want to modify the room's appearance in any way in post, or like after the dungeon done generating signal. You could do a bunch of things to modify the appearance of the room. You could even randomize it upon that signal. You could do a bunch of various things with that. Yeah, so hopefully that is pretty good. One thing people also asked me about is how to spawn the player in the dungeon. I mean, there are numerous ways to do this. You could do this in code, but one simple way I'll show really quick here is, say for example, we have our dungeon that we created here. And then if we added like an entrance room, so in this case, I'll just use this one that I already have here. So like if I added to this entrance room, and the minimum and maximum count is 1, that's important for this. So it's always going to spawn only one of these rooms ever. And if I just drag my player into that, then once like the dungeon gets spawned in, at the same time the room gets spawned in, the player will get spawned in with that. So that's one way to do it. Obviously, there are a lot more sophisticated ways. There are numerous ways you could do that. You could put like a node with a group on it, and then on the post generate signal, you could get the position of that node with the group on it, and then you could like position the player there or spawn the player in there with code. Numerous ways you could do that, but yeah, here, like if I just drag the entrance room on, it's going to spawn one of that in our generated dungeon here. So I remove the player from the scene, put him in the entrance room, and now when I spawn in, I'll spawn in the entrance room, and you'll see the dungeon is generating around us. And of course, this is visualizing the generation is on. That's not necessary to have that on. You can turn that off. That's just for like a showcase here. But yeah, now we're in this dungeon that is generated like before, but now we have the entrance room also tagged onto that as well. So we're spawning the player in the entrance room. We also have our pre-placed room that's this dungeon is still connected to here. So numerous ways you can get the player in the dungeon there. And yeah, I think that just about covers all the functionality there. Probably go over some of the code now to give you a bit more of an in-depth idea. First thing I will show, I got this question I think a couple times. If you're using this for multiplayer, one thing you can do is, so you're going to want to not have it generate on ready. Obviously, if you have it as the same seed for both players, for all the players, then it's going to generate exactly the same. But usually you probably want to generate it differently every time. So what you can do is, I included this script, random number multiplayer, extends regular node, and then this is just a really basic script I whipped up to generate a random number once only on the multiplayer authority, so like the server, and then for all the other clients, they just sync up with the server to ensure it's like the same random number. So it's only generated really on the server randomly. And then it emits this got random int function signal, and then you could do something like connect the signal from this onto the dungeon generator 3D, and then you'll see the generate function takes an int there if you connect it to that. So like on ready of this random number multiplayer, it's gonna call the generate function on the dungeon generator 3D, and now I have generate on ready off. So then if I run it, obviously the signal from the random number is gonna hit this, and then I'm not running multiplayer right now, but if I was, and other players were connected to the same to me as the server, their clients would get the same random number, and their clients would have their dungeons generate signal triggered independently, but all with the same integer, so everyone will get the same dungeon layout. All right, now one thing I kind of glossed over here was the custom, what is it called again? I don't even know what my own code's called. Custom get rooms function. So you can set this function on the dungeon generator 3D and supply it a list of rooms. Is this outdated? This is outdated. So it should return an array of the dungeon room. I got to update the documentation here. Hopefully this will all be done by the time that you see this. But yeah, I'll hopefully update all this, and then the GitHub wiki will be hopefully up as well. But yeah, the custom rand room function, ignore what it says here. I just changed the functionality recently. I think the new functionality makes sense. This gives a bunch of control over how the dungeon generates. So this example here. where if I generate it, it's this example where I'm only putting red rooms on the left and blue rooms on the right. And how I do this is just I supply the entire list of rooms for the dungeon myself. And yeah, this gives you more control over exactly where you want the rooms to be placed and everything. So yeah, take a look. What I did here was I inherited, you don't necessarily have to inherit, but this is just the way that made sense to me. As long as you override the custom get rooms function before the dungeon generates, then it will call your custom get rooms function, and whatever it returns, an array, it should be an array of dungeon room 3Ds. It will use those rooms to generate. And how you position the rooms, you use this function, set position by grid pose. This is a function on the dungeon room 3D class. Where is it here? Set position by grid pose. And yeah, so this is the position on the voxel grid from like the minimum corner of the dungeon room 3D, if that makes sense. And even if you supply a room like outside of the grid, it'll like push it within, so it's probably fine. But yeah, hopefully that makes sense. So there's like the voxel position, and that's different from like the Node 3D's instance position in the Godot scene. So like, I actually have, I think, the grid positions. Yeah, so like this is X0, Y9, Z9. This is, so like 0, 0, 0 is the bottom left corner of the dungeon generator 3D, and 999 is the top front right, I guess, because it's a 10 by 10 10 by 10 by 10 dungeon. And yeah, so you can set the room's grid pose. So like if I set this room here to like 0, 0, 0, that would place it in this little quadrant grid voxel square right here. And it sets it from the bottom corner, or like the min corner of all the coordinates. So the min corner of the AABB, you would say. So this is the function you would use here. And again, this code is available in the SimpleDungeons repository under the custom random room function example folder in the SimpleDungeons folder of the add-on. And yeah, so here I have in the dungeon generator, like preset, I have it to have this blue room here, and also this red room here. And then I place those just as normal on the room scenes property. And then in here, I'm getting the blue room and red room by name because this function will be called by the dungeon generator 3D with these two properties. So it's going to pass you in the list of room instances that are available for you. And then it's going to pass in the RNG random number generator seeded with the current generation seed that you can use. So any like randomness you need to put in, you should use this. So like it will be consistent with whatever seed you use, and it's deterministic, and it's going to be the same layout every time because you're generating it based on a seeded random number generator. So it's predictable based on whatever number you seed it with. And then yeah, the functions you're going to want to know here is setting it by the grid pose. Hopefully that makes sense. And this function is important here. It should warn you if you don't use this, but create clone and make virtual unless visualizing. This creates like a phantom clone room. This is important for threading and just for generation time. Like if I was spawning instances each time in like the generation phase, like it would massively slow down generation time. So instead, I just spawned like a phantom clone of the room with no actual like models or anything in it. It's just like an empty thing that looks at the original. So until it's actually spawned in, we just use clones. So this function is always going to return a list of these clones positioned to these positions. And then you can also set Dungeon Room 3D has this rotations property, room rotations property. And you can set this to an integer between 0 and 3 for how many Y rotations. So how many 90-degree rotations. So because it's on like a voxel grid, it can only be in increments of 90. So 1 would be 1 on the Y-axis rotation. 2 would be 2, or 2 would be 180, 3 would be 270, and 0 or 3 or 4 would wrap around to 0. So it's only a 90-degree increments. So you can set this if you want to like randomize your room rotation. Otherwise, it usually does that randomly, automatically when generating dungeons anyway. So if you wanted to, you could also do that. I'm not setting mine, my rotations, but I could here. This is where you would do it if you're using this custom get rand rooms function. So setting the positions, grid pose, and then here I'm just keeping track of a list of all the rooms, and then keeping them in an array. And then when I return this array of dungeon room 3Ds, the dungeon generator 3D will receive that, and then it will know that is what you want to place in the dungeon, and then that way you can get fine-grained control over the placement of all the rooms within the dungeon. So yeah, just to show here, got a lot of functions here. Where is it? Place rooms. Where the heck is place rooms? Place rooms. Place room iteration. Yeah, so in here it just checks if you have defined this custom get rooms function, and if so, it'll call it and run some checks to make sure you didn't pass it some bogus array and to like let you know what you did wrong if so. And yeah, that's how you manually pass in rooms, which gives you fine-grained control over exactly how the dungeon would generate. Maybe you have like biomes or something. You could do virtually anything. Hopefully this leaves a lot of options for what exactly you want to do. Little gotcha, I just remembered here. If you're setting the room rotations when you're manually placing it, you want to like set the room rotations before the setting the position by the grid pose, because that could actually be different because it sets it by like the minimum corner of the AABB. If it's like a uneven shaped room, when you rotate it, that could end up changing to not lying on a voxel. So for like correctness, it'll probably work either way because it'll just snap it back to the right pose. But to be correct, it would be correctly set before you set the grid pose. Yeah, it doesn't really matter here because it's just like 1 by 1 by 1, perfectly symmetrical on all axes rooms, so you don't really notice they're rotated at all. But that is how you would do it if it did matter, if you had like weirdly shaped like 2 by 3 by 4 rooms or something. And yeah, this map is pretty cool. This one generates a nice maze here. And yeah, it sometimes lags at the end stage. I think that's because I'm modifying like a ton of CSG cuts at once. It's most likely a big part of it. And yeah, this map's pretty cool. It's like gives you a pretty cool maze to zoom around in. These dungeons can get pretty trippy pretty quickly. This one's really easy to get lost and very like disorienting. It kind of reminds me of that one movie, The Cube or something. That was a good movie. I liked that a lot. It's like that horror movie where you're just walking around in like infinite cubes like this. It's like some alien thing or something. Pretty good movie. Yeah, so I think that covers pretty much everything. For the rest of it, I'm going to go over a bit of what the code does. I'm going to try to go quick because this video is already almost an hour. I'm going to look at the recording in Kden Live. And so I'll try to give a balance between giving some detail so it's useful and not going into too much detail here to make it like 2 hours long. So yeah, the Dungeon Generator 3D class is where a lot of the action goes on. A lot of this class is actually like just boilerplate stuff. So I got all the like settings up here, which I already explained. Init stuff. A lot of this is like setting up the debug view. So I have all the debug views like in their own separate nodes to separate the logic of that. Setting up debug view stuff, variables, And yeah, in this part of the code, the entry point, so you call generate. Most of this is still just boilerplate. I got to condense this so much if I didn't have to deal with like the visualization thing and the threads and making it all work seamlessly, but I like having that, and it makes it much more performant and whatnot. A lot of the difficulty of this was just keeping the code like simple while also getting performance going. And then a ton of it also is just the debug info and validation stuff here. So most of this is like not too interesting. That's all I'm really going to say about it. Useful functions here. This is a useful function. Like you might actually use this function here on the Dungeon Generator 3D. So on the Dungeon Room 3D, like say you're modifying how a corridor looks. I showed that get room function before. Maybe there's some use case for actually checking this function directly, so you can like loop through the doors, and then the doors themselves, where the heck are the doors? Doors have the exit pose grid, so that's where the exit position of the door would land. So like right outside the door of the dungeon room, what grid square is that on? That's what that variable is. So you could say like door exit pose grid, and then you could check what room is at the position. That's exactly how this function works actually. And then we, for the get room leads to part I showed earlier, and then I also check if it fits another door, as in like their exit positions and interior positions. Their grid poses and exit pose grids match up. That means like they're perfectly flush with each other, pointing directly into each other. So it'd be two rooms leading into each other. Yeah, so you might actually use that, the get room at pose. And yeah, a lot of this stuff is just validation and boilerplate. You might look in the, if you're getting into modifying the code and stuff, you might look in the util functions section here in the Dungeon Generator 3D, or I have a similar section here in the Dungeon Room 3D. Probably the only ones you would use would be supposition by grid pose, get grid pose, getting, maybe you're transforming stuff from dungeon space to grid space. This is kind of a confusing system because rooms can be rotated, and then there's like a voxel grid on the main dungeon, and then it's like the doors are still at their same voxel grid position relative, rotated. It's pretty confusing, honestly. This was the simplest way I actually went through like a few iterations, and this was like the simplest way to do it I could find. It has like a local voxel grid of where the doors are, so like 0, 0 or like 1, 0. But if it's rotated, that could be like y -1 instead of like x 1. Bit of a confusing system with the doors and whatnot. So that is a probably confusing thing if you're trying to read this code and figure out what I'm doing here. Also, if you have any questions, I mean, I'll probably just reply if you ask me anything in the comment. Feel free to ask me any questions about the code. If you're modifying it, please, go do whatever you want. CC0, public domain, use it for whatever you want. No need to credit me and whatnot. That's why it's CC0. But yeah, so maybe you would use the X form, the transforms, more likely the get grid AABBI. Maybe you would use this and just a Boolean to see if like the room's AABB, which is like the voxel representation of it in an access line bounding box, if that should be expanded to include the doors or not, and whether that includes optional doors. Notably, this like for stairs, it generally always includes the optional doors because it's kind of implied that so like optional doors, like an optional door could be flush right with the edge of the dungeon, which wouldn't make sense because for a stair, because like usually you want stairs to be able to connect, and if the door is like flush right with the like side of a dungeon here, it can't connect to anything. Like if the door's on this side, can't connect to anything. So yeah, so the stair, that's true. Minor detail there, but hopefully that's maybe useful to somebody. I don't know. Let's see, what else? So yeah, get grid AABBI. That might be useful to you. Maybe snap room to dungeon grid. That could potentially be useful. Probably not actually. Probably just setting the grid position and getting it. Getting the grid AABBI and setting it. That's AABB integer only. That's like a custom utility class I made. It's just a regular AABB essentially, but it uses all vector 3i's instead of vector 3's because it's like in voxel space. And if something's overlapping, I want to check in voxels, not in like floats. No precision issues. Yeah, so that's pretty much it for the Dungeon Room 3D. The doors are a little bit confusing, the doors and the transforms and whatnot. I might want to clean this code up later at some point and switch how I'm doing this. I think there still could be, it was kind of difficult for me to keep this simple and also stay performant and whatnot. So might have to think about how to refactor this to make it simpler and more performant. Yeah, so that's that. That's some actual functions that you might actually use. Let's see. Yeah, Dungeon Generator also has a get grid AABBI, which basically just serves that basically just returns the dungeon size. This is because I have some functions in the AABBI for like snapping to grid and pushing them within the bounds of the dungeon generator. Yeah, so that is that on the Dungeon Room 3Ds. Yeah, so most of this I'm not going to talk about because it's like threading stuff that was just kind of boring and like annoying to get working. Just like setting up mutexes and then this whole system of like, the cloning of the rooms. That was kind of a headache, but it's pretty much necessary for performance. You get to encapsulate all this logic in this Dungeon Room 3D node, keep it simple. But then you don't want to be like instantiating this every time because that would make it like insanely slow. Like if you had like a bunch of models, yeah, that could potentially be really slow. And also to do it in threads, clones are also relevant for that. Because this was annoying to get working. The doors cache. So like the whole thing is you can't from threads access like most things, even if you're not touching it in the main thread at all in this while working in the side thread. You still can't touch most things related to a node, even if it's not even in the tree. You can't set its transform. You can't set a lot of stuff on it. So I had to do some monkey business here. And if I know some people mentioned to me they were interested in modifying this, this is probably just going to be a headache if you want to go over this. It was for me to get this working, and even here I wrote a comment. Like, I don't know why this would be erroring accessing this, but I had to put a mutex on this variable, which a mutex is making sure multiple threads don't access a variable at the same time. Even though I wasn't accessing this in the main thread at all, I don't think. So, yeah, maybe it was over-sensitive thread guards in Godot, but it was a kind of a pain in the butt to get threads working and this business with cloning and whatnot. So that is that. It's a bit confusing. Would love to simplify this. That's one thing. If anyone has any suggestions for how to simplify it, I'm kind of hesitant to add a much more stuff to this. I like the idea of just keeping it modular and simple, yet flexible and unopinionated on what you're able to do. I think this current version offers a lot of freedom if you really think of creative ways to use it. I think you can probably think of ways to do a lot of what you want to do without having to modify the code. Just with the whole pre-placed room system, modifying rooms in post, like right after generation. I think there's a lot of flexibility there and potential for, just a lot of creativity if you get a little bit clever with utilizing what's here now. So, yeah, that is that. And then I guess I'll go over the generation loop a bit. So, yeah, we got the generate function. This is the entry point. Do a bunch of cleanup and whatnot and getting ready for using threads, and then we go to this run generate loop function, and then this just keeps track of the iterations and making sure it doesn't go past their max number. Same with the retry attempts. And then it's calling this run one loop iteration function here. And then each of these stages, once they're done, it increments the stage variable to go into the next one. And yeah, then once we're done, it'll go into the finalizing stage. We'll break out of this and like place the rooms and whatnot. But yeah, that's mostly all boilerplate. The interesting stuff, I'll try to go over most of the important stuff here. Place rooms. Kind of already showed this. We are, and if you supply custom rooms, we're just placing them potentially not in the tree. If we're visualizing it, we'll place it in the tree immediately. Otherwise, it's kind of like saved in this temporary variable rooms container until you actually place the rooms container in the scene. So yeah, we created this rooms container, place it in, place our rooms while we're generating it, and those could be cloned rooms, and they won't like get instantiated until the very end when we finalize the dungeon for performance. So yeah, that's pretty much it for the rooms placement. It places all the rooms till we're done, until there's all the min and max count are met. Stairs, this is a bit confusing. I have this thing, make and solve floors graph. And yeah, where most of the action is going on is in this make and solve floors graph function. This just gives you all the positions of the rooms, and then once we have those, we just set the positions and spawn the stairs in. So this function, it uses a union find algorithm basically, which like essentially, I could show you the class here, I guess. Utils tree graph, call it a tree graph. It's union find. It places the rooms into buckets and then keeps track of which rooms are connected. So if 1 is connected to 2 and 2 is connected to 3, 1 and 3 aren't directly connected, but they're indirectly connected by 2. So that would mean the floors 1, 2, and 3 are all fully connected. So we want to keep track of which floors are connected. That's the goal in adding stairs, to make sure all the floors are traversable all up and down the dungeon, and the rooms are going to be indeed reachable. So yeah, this is admittedly a bit confusing. I'll quickly go over this. If you're in this deep, you might as well look at this yourself. So yeah, we're just checking, can we directly connect any of the floors with the stairs based on the Y positions of the span amount between the doors. So like if it's a stair that spans one floor, then we can check if we can connect any floors that are one apart. And this is like a heuristic thing. I don't think this algorithm is perfect. Basically, we're just doing a kind of crude way of checking if we can directly connect any floors. If we don't find that, then we try to look for like a stair chain where we find more than one stair room that can connect two floors. So like if two doors were like far apart, or there were two rooms, the one was on the bottom of the dungeon, one was on the top, you would need like a chain of like 5 stairs of 2 high to get up like 10, the distance between them, whatever. So that's basically the concept. It's just like a heuristic algorithm here. There's not all, I mean, there's some thought put into this, but it's not any sort of like mathematical perfection, anything. It's just a heuristic. I tried to catch a good amount of cases or so. I think it's worked on everything I've tried. If anyone reports any bugs, I'll fix it, but hopefully this works for most things here. And then it's going to warn you and like error out if with some explanation if it fails at any point. So that is the stairs connection phase. And then the separate rooms iteration. And for the separate rooms, if you saw my previous video on my dungeon algorithm, basically goes like this. We spawn a bunch of rooms, then we just like push them apart with like a pseudo collision detection physics type of thing. We just push them away based on which side they collide on. We just push their positions away from each other. We spawn them in randomly and then push them away. It's even possible for it to get stuck. Let's see if I can find somewhere where it gets stuck on this. Yeah, so it's even possible that it can get stuck. This is where like just restarting the algorithm would come into play. Like it's just like a bad room configuration. And so we would just restart from here. Yeah, so that's all that is. And it's actually done like only on the X and Z. It's only separated horizontally. Yeah, it's only separated like horizontally. They're pushed away from each other, X and Z. This is so like when we do the stairs connection phase, like all the floors that are connected are going to stay stable. So you don't, it's like simpler than just pushing it all over the place, and still offers like good amount of randomness. Seems fine. Yeah, so it just uses this. If it's not a pre-placed room, pre-placed rooms are going to be like stuck in place. So we're not going to push away in that case. But yeah, we just use this very basic push away from function here that, yeah, if it's to the right, it goes, pushes away to the right. If it's to the left, pushes away to the left, up, down, down, just pushes them away. Simple as that. Pretty easy, stage here. Connect rooms, this gets a little bit more interesting, and this is the last stage of it. And this is pretty straightforward, actually, I think. So we just get all of the rooms. This is just some stuff set up for performance, like a dictionary, instead of recalculating and checking every time the position of the rooms and which rooms are at which positions. Boilerplate stuff. And then I'll show this in a second, the Dungeon A* 3D, but pretty simple. We path find all the rooms one to the next, and it's able to move horizontally when it's not in a room, so path find outside the rooms, and then if it finds like a stair room, then it can path find down. So we just have this whole big A* grid with the appropriate nodes connected. So yeah, just path finding one to the next and then adding the corridors. Pretty much all we're doing here, pretty simple. And then the required doors, slightly more complicated, I guess. Yeah, like until this part is done, we just return and then wait till the next iteration. And then after we're all done connecting all the rooms, we have to make sure all the required doors are connected, because they might not have been connected by that point. And this is where we let the user decide if like, should this door always 100% be connected? If so, then we gotta make sure it's connected here. So all we do here is just, I mean, we could just like cap like a single corridor on that grid position, then that would technically work, but that would make some pretty crappy layouts. So I do some heuristic here to find the closest room to that door position and then pathfind to that. Maybe there's a better way to do that, or a more interesting way, but the dungeon generations seem pretty good for now, so we'll see if it stays like that. And then, yeah, that's pretty much everything. I'll also quickly go over the Dungeon A* Grid 3D. So we're extending the A* 3D class in Godot. If you extend that, then you can define some custom stuff, such as the compute cost and estimate cost functions. Probably beyond the scope a bit to explain what A* is in this tutorial, but yeah, what I'm doing here is like every voxel position is a node, is what it's called in the A* grid. And then when you connect 2 points on two nodes, then the algorithm basically can pathfind or walk between those 2 nodes. So I connect the points, I basically connect everything except where our walls are, and then I don't connect like up and down outside of rooms. So like you can only walk down or up if there's stairs, otherwise you can pathfind between the rooms as much as you want. So yeah, just to have this function check if we can walk through a room. That would be not walking up and down unless we're in stairs, and not walking through walls. And that's basically what that does. And we just connect the points where it makes sense according to that. So the estimate cost and compute cost functions, these are used for pathfinding. So what Dijkstra's and like A* actually is might be a bit out of scope in this tutorial, but Try to give a brief explanation. So whenever we're pathfinding, so like here, it's this utility function I just made to return the path like in the voxel space, because the A star 3D works in vector 3s. So when we're pathfinding, the A star lets us get a path between any two nodes on the path, or at least tries to find a path. Sometimes there might be like walls or something blocking us from getting there, so it's not guaranteed to be able to find a path in all cases, but it tries to find the lowest cost path, we say, to the destination. So like ideally we want, like if there's a goal straight ahead, we want to go straight ahead. We don't want to like zigzag 10 different ways to then get to the goal. We want to find the lowest cost path, shortest distance possible to travel to get to the path. Usually that's what we want. And the estimate cost and compute cost let us modify this. So as an example, and the compute cost, this uses the corridor cost, room cost we set here. And like we want to encourage the pathfinding to go and to reuse existing corridors. Usually, here's a generation I did without reusing corridors. You can see like this is a lot more bulky than our previous setup. It has like just like this like double thick corridors here when they were more thin before. So when the path is like, when the cost to go through a corridor is less, it tries to find the lowest cost path. So it'll try to reuse the corridors, and it makes them like less bulky like this essentially. That is the point of that. Yeah, the entirety of A star might be a little bit out of scope here, but this compute cost essentially lets you modulate how much it costs to go through what and encourage the pathfinding to, like it always tries to find the lowest cost. So if you make the cost less or more to go through certain places on your A star grid, the pathfinding is going to tend to the lower cost, whatever you set that as. And then this estimate cost, yeah, might be out of scope a little bit. What is A star pathfinding? So A star is like a improvement upon Dijkstra's. And what Dijkstra's basically is a brute force pathfind to the shortest path. It's like a dumb but very accurate, slower but very accurate brute force pathfinding to the lowest cost path. It is guaranteed to always find the lowest cost path because it literally just brute forces through all of them. So that you can imagine is slow to do that brute forcing. A star adds something called a heuristic. So instead of just brute force checking every path, what we can do is say like, hey, like it would probably be easier to first check the paths which are getting us closer to our destination. That would make sense, right? Rather than just, oh, hey, I need to go to this room ahead of us. Let me first try going backwards and see if that actually gets us closer. And that would actually be correct in some cases. Like say you had some weird zero cost path behind you. Then in that case you would, Dijkstra's would get you the correct answer doing the brute force way. So if you, the A star is only guaranteed to find the shortest path if what we say is the heuristic is admissible. So, you know, that logically checks out. Okay, we want to check the closest nodes first. We want to check there first. If we have multiple options, always check the closest one. But that's not going to work if it's some weird thing where the costs are variable, and that means the heuristic is not admissible. Basically, I think I'm using the terminology right. Essentially, that's not going to be accurate if we check the closest path first, but that ends up being a higher cost somehow because of where it's set up. Such as like we have corridors behind us, and that ends up being lower cost than going straight directly towards it. So this is the basic explanation of that. Heuristic adds a heuristic on top of Dijkstra's, the brute force, to first check the nodes which are closest by this heuristic. Manhattan distance, closest by the addition of the x, y, z from the goal, or closest based on Euclidean, which is the absolute distance, which is like the diagonal distance, if you want to count that. And the reason Euclidean is preferable, I think, is because it, if I recall, prevents zigzagging corridors, which I noticed that heavily when I first implemented this, and I used Dijkstra's because I thought that was preferable. But in fact, you're probably going to want to use Euclidean because you're probably going to get weird corridor shapes if you use Dijkstra's, and you can still get a lot of the it's going to be like almost always accurate, even if not perfectly, if you use A star. I have found, at least, like it's still very good even without Dijkstra's. That's not going to like go all crazy and find some weird path, even though it's not brute forcing every possible thing. So yeah, that is pretty much everything there. I think I covered just about everything. I hope you found the source code explanation useful. Again, feel free to ask in the comments if you have any questions. And yeah, thank you for watching, and I hope you enjoyed the tutorial. So yeah, that is the video. I hope you enjoyed. I hope you found it useful. Feel free to leave any questions down in the comments. I got a lot of good feedback on this. I was really happy to see that people are actually using this for games and stuff. Really cool to see a couple of you sent me stuff you built with this. Really awesome. I hope this new version will be good, bug-free, easy to use. And yeah, if you find any bugs in it, this new version I just made is still pretty fresh. Might have some bugs in it. I'm gonna keep looking at it for a couple weeks pretty heavily, and try to fix most of this stuff. But yeah, just ping me in the comments. GitHub issues, Twitter, some of you on Discord. So hopefully this is all good for you. Hopefully everyone enjoys it. Definitely keep sending me the cool stuff you're making with it. I always like to see that. And that is the video. One thing I will plug is I have a Ko-fi, Coffee, and Patreon now. So if you want to support the channel and you want to see this channel grow, and you want to support more development of these add-ons, more add-ons in the future, and help me be able to spend time maintaining these, consider giving a one-time or subscription-based donation on Patreon. If you just want to do a one-off, you can do it on Ko-fi. Anything helps. And yeah, either way, I hope everyone enjoys the add-on. I hope you enjoyed the video and have fun using it. And let me know if you need any help in the comments.